Good day, everyone. So today I'm going to share with you another discussion video about the volume of a solid of revolution. Let's move on to the example number 2. Problem number 2 is all about find the volume form by revolving the area bounded by the curve x squared is equal to 4 quantity x minus y, the y-axis, and the line y is equals to 1, and it will be revolved about x axis. So the first thing that you need to do is to know the details of your graph. So we are given by a parabola here. So we need to transform that parabola into its standard form. So this is equal to x squared equal to 4 quantity x minus y. X squared is equal to 4x minus 4y. Then I will need to transpose 4x to the other side of the equation. So we have x squared minus 4x is equal to negative 4y. So I need to add 4 and subtract 4. So I have x squared minus 4x plus 4 minus 4 is equal to negative 4y. I need to complete the square. This is x squared minus 4x plus 4. Transpose number 4, negative 4 to the other side of the equation. So we will have negative 4y plus 4. So I need to transform my equation of the parabola into its standard form. This is equal to x minus 2. This is the factors of x squared minus 4x plus 4 equals to, I need to factor out negative 4. So I have negative 4 quantity of y minus 1. So therefore, my vertex is 2 and 1. And this parabola, because you have negative 4 here, so it is facing downward. So now, after that, we need to get the intersection points. So based on the problem statement that we have, we need to get the area bounded by the curve, the y-axis, and the y is equal to 1. So at y is equal to 1 from the given vertex here, x is 2. So let's try to check if it's 2. So we need to substitute the value of y to the equation of the parabola. So we have y is equals to 1. So we have x squared is equal to 4 times x minus 1. So you have x squared is equal to 4x minus 4. So transpose this, x squared is equal to transpose. So we will have x squared minus 4x plus 4 is equal to 0. So the factors here are x squared. So we will have just to put the factors now. This is quantity x minus 2 squared is equals to 0. Right? We have x minus 2 is equals to 0. We have x is equals to 2. Therefore, one of our intersection point is 2, 1. Now, at x is equals to 0 because we have y-axis as one of the conditions to get the area bounded by the curve, the y-axis, and the line. Y is equals to 1. So at y-axis, x is equals to 0. So therefore, the value of y is 0. Right? Just substitute the value of x, which is 0, to the equation of the parabola. So you get y is equals to 0. So I will show you how. That's 0 squared is equal to 4 times 0 minus y. So you have 0, negative 4. So negative 4y all over negative 4. Then you need to divide both sides by negative 4. So you get the value of y as 0. So therefore, one another intersection points is um, 0, 0. So therefore, intersection points by the given problem statement that we have are 2, 1, and 0, 0. So we do have the details of our graph. Now we need to graph it. Now we are already given with the details about our enclosed region. This is the time to plot it. So imagine that I draw my Cartesian plane perfectly. So we are given with a parabola which is the vertex is 2, 1 and it is facing downward. So this is 1, 2, and this is 1 here. So our vertex is somewhere here. So this is vertex 2, 1. So our our parabola is facing downward. So according to the parabola, at x equals to 0, y is 0. So here, which is x equals to 0, or the y-axis part is a part of our um condition to get the enclosed region. So our parabola is like this. It's facing downward. So we need to label the parabola. This is x squared is equal to 4 quantity x minus y quantity. And one of our condition is at y is equal to 1. When y is equal to 1, x is 2. So this is equal to y is equals to 1. So now we already have the enclosed region. We have the closed region which is located here. Why it's here? Because according to the problem, we need to get the enclosed region by the curve, which is the parabola, y is equals to 1 and the y-axis, or x equals to 0. So this is the area bounded by the conditions that we have. And this area should be revolved around x-axis. So for us to get the volume generated by revolving this area around x-axis. So with that, we need to know what strip that we will use. For this example, we could make use of the dy strip or the dx strip. So for this example, it's better to make use of the dx strip so that we could make use of the circular ring method. Why it's circular ring? Because the bottom part of my strip doesn't touch us to the axis of rotation, which is x. So in circular ring method, we need to know the distance from my upper part of my strip to the axis of rotation. Let's represent the distance from the from the upper part of the strip to the axis of rotation as y upper. And the distance from the lower part of the strip to the axis of rotation is y lower. Now, we could solve for the volume generated by revolving this area, which is volume is equal to pi, according to the circular ring method, integration of y upper squared, that's the distance from your axis of rotation to the upper part of your strip, minus y lower squared, that's the distance from the lower part of your strip to the axis of rotation, quantity dx from A to B. So this is now our working equation. Now we could substitute the values that we have. So volume is equal to pi integration of our y upper. Our y upper is from here to this line. So the distance is 1, right? Y is equals to 1 because this part here is y is equals to 1. So you have 1 squared minus quantity. our y lower, as you can check, our y lower or the bottom part of our curve touches the the bottom part of our ship touches the curve. So, therefore, our y lower is the curve. So, to get the y lower, you need to isolate y to the equation of the parabola. So, you have x squared is equal to 4 quantity x minus y quantity. So, x squared minus 4x is equal to negative 4y. So, we need to isolate the value of y. So, divide both sides by negative 4. So we get y is equal to x minus x squared all over 4. So this is now the value of our y lower. X minus x squared all over 4. Okay, I'll just rewrite it. So I have x squared all over 4 quantity dx from our lower limit, which is 0, to the upper limit, which is 2. So it is in terms of x. So in circular ring method, you need to subtract the volume generated by the y lower if you will try to revolve it around x-axis to the volume generated by revolving y upper around x-axis. So you could form a circular ring, right? With that circular ring, it will run from the lower limit to the upper limit so that we could get the total volume generated. So that's what we are doing here. So let's try to manipulate our equation. So we need to expand this. So for us to um, integrate it easily. So we have volume is equal to pi integration of 1 minus, this is equal to the quantity of x squared minus x to the third power all over 2 plus x to the fourth all over 16. Right? Quantity dx. From 0 to 2. So we could manipulate it. We could integrate it immediately now. So this is equal to v pi. So integration of 1, that's x minus. Just distribute negative sign to each term inside this parenthesis. So this is equal to minus x to the cube all over 3 plus x to the fourth all over 4 times 8, that's 8. 4 times 2, that's 8. Plus that's minus x to the fifth power all over 16 times 5, that is 80. Quantity from 0 to 2. So we need to substitute the upper value to the value of x. So 2 is the upper value. So we have volume pi times 2 minus 2 raised to 3 all over 3 plus 2 raised to 4 all over 8 minus 2 raised to the fifth all over 80 minus the lower limit, which is 0, and we need to substitute the value of x into 0, so we just simply get 0 for the whole term when subtracting the lower limit. So volume now, just input this in your calculator, you can get